A wooden roller coaster consists of metal rails attached to wooden beams. The wood cushions the jarring of the wheels on the rail. The ride begins with an uphill chain start. As the train is towed to the top of the first hill, it gains stored or potential energy. As the train edges over the crest of the hill, gravity takes over and pulls the train towards the earth, converting the energy to motion or kinetic energy, which allows the coaster to fall down at a constant rate of 9.8 meters per second squared. The transfer repeats on the next uphill. Each hill must be smaller than the one before it because the moving train loses energy through friction when it contacts the track until it is towed again. Roller coasters also introduce the concept of G-force. G-force is the measure of downward pressure on the body, and twists and turns subject the rider to positive or negative G-forces. As the train reaches the bottom of a hill, the rider continues moving downward, but the train begins to move upward. At the top of a hill, the body is still traveling upward, lessening the pull of gravity while the train moves downward. This weightless feeling can also be felt at the top of loops. No engine is required to keep the coaster moving because of inertia. The law of inertia holds that an object in motion will stay in motion unless acted upon by an equal or opposite force. These forces include friction between the wheels and the track and air resistance against the car as it moves along with the help of some air brakes near the end of the ride.